All right, so I'm going to go through all the questions that were given to you in review. So if you need to, you can watch this video. You can skip through everything. You don't have to watch it all without being able to skip. So you can go to just the problems you have questions on. So to find the mean is we would add up all of these numbers here. So when we add all them up, it will be equal to 1649. And we divide by how many we have, which they tell us is 15. So we divide by 15. So that is then equal to 109.9. So that is our mean. Our mean is 109.9. So we would add up all of our numbers and then divide by 15. To solve for the median, what we need to do first is we need to rearrange these numbers in order. So it'll be 60, 68. I'm going to pause this and just refill them in. All right, so we would write them in order from least to greatest. And since it's 15, 15 divided by 2 is equal to 7.5. So that means our eighth number is our median because that will give us 7 on both sides. So whenever it's odd, it's going to be whatever this number would round up to. So it'll be 1, 2, 3, 4, 5, 6, 7. So our median is 97. So the answer to B is 97. The mode is which one occurs the most. So 114 occurred twice. So our mode will be 114. Our mid-range, we take the smallest number, so 60. We add it with the biggest number, so 229. And then we divide by 2. So 60 plus 229 will be 289 divided by 2. And then this will be equal to 140. Let me write it down here. 144.5. Right, so our mid-range will be 144.5. For E, our range, that one will be our largest number, 229, and we just subtract our smallest one, which is 60, so that will then be equal to 169. I'm not going to go over F and G because I want you guys to use a calculator for that, but the answer to F was 2007.1, and then the answer to G would have been 44.8. All right, I'm going to see if I can find an emulator on here to create a video to show you how to find your standard deviation using a calculator. But we've gone through that in class. So that's question number 1. All right, so for here, whenever we want to find the mean of our frequency distribution, we need to create or extend this table. So I'm just going to extend this a little bit more. And we need to find our midpoint. And then we need to do our midpoint times our frequency. And then there's one more column that we need to solve for, and that's our midpoint squared times our frequency. We will use that for finding our standard deviation. So our midpoint is we add our two numbers and divide by 2. So our midpoint's 2, 5, 8, 11, and 14. Then our midpoint times our frequency, so 1 times 2, let me do this in different colors. So that would be 2, 5 times 4 is 20, 8 times 5 is 40, and then 11 and 14. And our midpoint squared times our frequency, so 2 squared times 1, so that will then be 4. 25 times 4, which is 100. 64 times 5, which is 320. 11 squared is 121, and 196. All right, then the last thing you have to do is you have to add up your midpoint squared times your frequency, your midpoint times your frequency, and our frequency. So we need to add all of those up. All right, so then from here, to find our mean A is we take our midpoint times our frequency, the sum of it, 87, and then we divide it by the total number of frequency that we have, which is 12. So that is equal to 7.25, but we would round this up to, if I asked you to, you would round it up to 7.3. All right, our modal class, that is the one that occurs the most. So it's the highest frequency, not the frequency that occurs the most. So although 1 occurs 3 times, that's not our modal class. It's the one that has the largest frequency, which is this 7 through 9. All right, our variance, we're going to find our standard deviation first, and then we'll find our variance off of that. So remember, the formula is the square root of the sum of our x squared minus the sum of our x squared divided by n over top of n minus 1. So the sum of our x squared is this 741. Minus the sum of our x, which is an 87 squared, all over top of 12, which is our n, over top of 11. Then we take the square root, so let's just go ahead and do everything on the inside. So 87 squared divided by 12, 741 minus that, divided by 11. That will give us approximately 10.02, so it's the square root of 10.02. So our variance is the number before the square root. So C, our variance is 10.02. And then when we take the square root of that number, it gives us approximately 3.2. So our standard deviation is 3.2. So our variance is the number before we take the square root. So when we're finding the weighted average, it's kind of like finding the mean for a frequency distribution. But here it says, in an advertisement, a transmission service center stated that the average years of service of its employees is 13. So what someone might have did to do that, because we're talking about years of service, they might have just added them up. 3 plus 6 plus 30. Well, that's equal to 39. We have 3 different categories, so that's equal to 13. So they'd say that that's the average. But that's not true. Because remember, when we find the average, we need to add up all of the data and divide by the number of data. Well, this is saying we have 8 3s. So if we wanted to write this out, we could write this out 8 times, because that's how many 3s we actually have. And then we would have 1 6 and 1 30. So we need to account for all of these 3s that we have. So what we do then is we multiply these numbers together. 8 times 3 is equal to 24. 6 times 1 is 6. 30 times 1 is 30. And then we add these together, and that adds up to 60. Because if we were to find the average of all of these numbers, we would add them all up. And it would add up to 60. And then we divide by the total number of data we have, which is 10, or the total number of data here, which is also 10. It's the same thing. 60 divided by 10 then is 6. So that means the real true average for years of service is this 6. All right, so once we have this problem, a survey car rental, and once we see it says Chevy Chevs, that lets us know that we need to use the formula 1 minus 1 over k squared. And k is how many standard deviations we have moved. And this formula tells us the percent of our data. So when they give us the percent and they ask us to find a range, we need to go ahead and plug it into this formula. Now, we've gone through a bunch of these problems. So when you see 75%, you might automatically know that that means k is equal to 2. That's fine. Just make sure you substitute it in and show me that you're checking your work. But it'll be 1 minus 1 over k squared is equal to 0.75 if you do not know that that's automatically 2. And then we just go ahead and solve for our k squared. So we subtract our 1. So it's negative 1 over k squared is equal to negative 0.25. Then we need to get the k squared out of our denominator. So we multiply by negative k squared. We're multiplying it by negative as well because both of those are negative. So we just want to turn it to a positive. This will cancel out. So we're left with 1 is equal to a positive 0.25 k squared. So to isolate the k squared, we then need to divide by 0.25. And we do that to both sides. So 1 divided by 0.25, I'll write it up over here, is equal to 4. And then we need to take the square root to solve for k. So that means k is then equal to 2. So that tells us how many standard deviations we need to move away from our mean. So what I will suggest that you can maybe do just to identify what this number is draw a number line and put the mean first. And then however many your k is, that's how many tick marks we need to move. So 1, 2 in both directions, 1, 2. And our standard deviation is 0.3, so that tells us how much we're moving along our x-axis. So as we move to the next tick mark, we need to add 0.03 to it, so 0.35. Then we need to add another one, 0.38. Then when we move to the left, we need to decrease it, so 0.29 and 0.26. Right? When you do this, whatever the numbers are at the end, that's your range. So that means that our data, 75% of our data will be between 26 cents and 38 cents. All right, so first we need to find the k to tell us how many spots away from our mean we need to move. And as we move, we're then adding our standard deviation to it. And whatever our final numbers are is our range of our answer. All right, so this one, it says Chevy Chevs, so we know we've got to use the formula 1 minus 1 over k squared. But in this time, it gives us the range, and we want to find the percentage. So we want to know, what does this equal to? Because the percentage is what it's equal to. So we need to identify, well, what is k? And once we solve for k, we just plug it into our formula. Well, the way we solve for k is we use our number line. And we put our mean right in the middle. It's 54. And then as we move our tick marks, our standard deviation is 4. We're just adding 4 to it. So it's 58. Well, 58 is not the maximum. And then the next one would be 62, which is more than the maximum. So that means we actually need to be somewhere in between here. We need to be at 60. So this, we've moved 1 standard deviation. And here, 60 plus 2, well, 2 is 1/2 of 4. So that means that here we moved 1/2 of a standard deviation. And we only need to do it for one way. You don't need to do it both. So that means our k is equal to 1.5 because we moved a a total of 1 standard deviation and a half. So 1 minus 1 over k squared. So then this will become 1 minus 1 over 1.5 squared, 1 minus 1 over 2.25. This will then be equal to 1.25 over 2.25, but we want it as a percentage, so we will just divide them, and that will give me 0.55 repeating. So then our answer would then be, because we want it in percentage, our answer would be 55.6%. Right, so 55.6%, a minimum of our data would fall between those two numbers in that range. All right, so this one is different because it says it's a bell-shaped curve. It doesn't say that it is. It does not say that it is that we're using Chebyshev. So we need to use this that we learned, where we then need to create a region. So I'm just going to pause this and fill in our regions really quick. All right, so remember, we'll need to know how to fill this in for question 1, but this is exactly what I'll provide for you in your test. And what you'll need to do is we want to know what's the range that 68% would fall in. Well, we know that this here is 68%, these two, when we're 1 standard deviation away. So the middle number is our mean, and our standard deviation is 6. So all we need to do is add 1 6-minute to it, so that'll be 35.7 minutes, and subtract a 6-minute from it, so it's 23.7. So that means our range that we'll have 68% of our data is 23.7 to 35.7 minutes. All right, and that is it for this one. All right, what is the value of the mode when all the value in a value sets are different? Keyword different. So that means maybe 2, 3, 4, 5. So none of the values repeat, not even once or twice on them. So when this happens, someone might be inclined to say that the mode is 0, but that's not true because we can't say 0 because sometimes we will have a 0 in our data set. So when no number repeats, the answer is C, that there is no mode. All right, so it tells us that we have a bell-shaped distribution. So remember, if it doesn't say Chebyshev's, then we need to use this. And this is exactly what you'll get on your test. You just need to fill in what's on our axis. So our mean or the average is 1019. So that means we need to fill in 1019 here. Our standard deviation is 110. So every time we move one, it's moving up 110. So this will be 1129. This will be 1239. And this will be 1349. All right, then from here, we subtract 110. So when we subtract 110, this will be 909. This will then be 799, and this will then be 689. So the first question says, how many will fall above 1129? So here is 1129 here. So this is our cutoff region. So how much will fall above it? Well, these are all the numbers above it. So we need to add them together, 13.5, 2.35, and 0.15. When we add those up, this will give me so this would then be 16% because 0.15 plus 0.35 will then give me 0.5. 0.5 plus 0.5 will carry a 1 over. 3 plus 2 plus 1 is 6, and this will then be 16%. So how many fall above 1129 is 16%. How many fall above 799? So here is 799. So how much falls above it? Rather than adding all these, we know that this will add up to 100%, our percentages. So we can then just add these two, 2.35 and 0.15, which is 2.5, and we can then just subtract that from our 100%. So that will then be 97.5%. So the number, how much will be above 799? That will be 97.5%. All right, that is it for all the review questions that you have.